Y'all ready? It does sound fake, but it's not. It's very real.
Is it easy?
It's very easy, okay? Now here's the thing. You can always use long division.
No.
But long division is long,
I
right?
get lost because it's so long.
Okay, so when the situation presents itself to use synthetic, it's way smarter for us to use synthetic division. But you need to be able to recognize the scenarios in which that occurs. Those scenarios are when you are dividing by x plus a number or x minus some number. And we generally call that number k. Okay. But only when, that's the variable we generally use. Only when you're dividing by this does it work. Not x squared plus 3, not 2x plus 4, but just x plus or minus some number can you use synthetic division, okay?
Oh, this can be
Now,
squared.
when we set it up, no. Let's say you had one in your homework that was, and this is number 5 from your homework last night, x squared, oh, that's cubed, I'm sorry, x cubed plus 3x squared plus 3x plus 2 divided by x minus 1. Does this scenario lend itself to synthetic division? Yes, because it's x minus 1, okay? If the x has a coefficient
If that is the irritant.
or an exponent, is it what?
If that is the irritant.
2. Most of these have lines through them.
That's a 2?
Yeah. If this second one has an exponent on the x or a coefficient on the x, this does not work, okay? All right, so that's the first thing is we have to be able to recognize.
So it has to have an
What if it
exponent
has-
and a number.
No, it can't have an exponent or coefficient.
So it's
Just plain old x, and then you
So
add or
why did you
subtract.
write that up there?
This one, see this one?
Yeah.
X minus 1, that's in that form of x plus something or x minus something.
So it's not right then.
It is right.
You just told me that.
No. If it looks like there's no number or exponent on the x, okay, and you're adding or subtracting something to it, then you can use synthetic division. Does that make sense? You'll start to recognize it as we go too. All right, here's what we do. We're going to take this division problem. All right, y'all know everybody always does this. When I first put it up here, don't start going, oh, I'm just going to do long division. That stinks. You'll get used to it. It'll go fast. I promise. That's my every student ever voice. And you will grow to love it. I promise you will.
We're going to call this.
Synthetic division. Upside down division sign.
I like the long division.
You didn't say it like, I like long division better. This stinks. Okay.
What is that? It's like an L.
Yeah, upside down division sign. All right, this number here that you're adding or subtracting to x, change the sign and put it outside. So I'm going to make it positive 1. Change it. And you'll see why soon. We'll talk about the factor and remainder theorems. No. If this was x plus 1, then it would be negative 1. All right. Leave room for 2 rows of numbers here. Okay. The first row is going to be the coefficients from this polynomial, including placeholders. Placeholders are crucial here, okay? So what are my coefficients? 1, 3, 2. Do we all agree? Here's the pattern. Just like long division is a pattern that continues to repeat itself, so does synthetic, okay? Drop the first one. Multiply What's 1 times 1?
2. Oh,
Oh my God.
I'll think about plus.
Multiply and add. What's 3 plus 1?
4.
4. Do it again. Multiply. What do you get?
4.
And add.
4 plus 3. Oh, you add like this.
Add the columns. Multiply and add. So after you drop that first one, it is a constant pattern of multiply, add, multiply, add, multiply, add, multiply, add. Now, if you flip back over to your homework, what number did I tell you this one was? Number 5? Yeah. If you checked your work when you did your homework, you should have gotten x squared plus 4x plus 7 plus 9 over x minus 1. Okay? Whenever you did that particular problem on your homework. Now, once you think about that, I didn't realize you couldn't see it very well. Let's see. X squared plus 4x plus 7 plus 9 over x minus 1. Can you see a relationship in the synthetic division and the actual answer you got? What is it?
It's
They're
1.
the coefficients. Right?
So what?
Catherine said they're the coefficients. Okay? Look carefully, and you want to start at the far right because this will always be my remainder column. Do I have to have a remainder? No, some things go in evenly. If that's 0, that's still my remainder column. It just means that's the remainder. What do you think's next?
X over 1.
If this is 9, here's the 7.
Wait.
If I put a C, what does that
How
mean?
did you get 9x plus 1? X minus 1. How did you get 9 in the first place?
I said last night you had this problem in your homework. It was number 5. When you did long division, this is the answer that you got.
So that's
I'm
not
showing
what
you.
it was.
No, I'm showing you how it relates back to synthetic.
So remainder.
So where's the X?
And then what's the C mean?
C is constant. And then you start with your x's. This column would be x. X squared. If I had another column, what do you think it would be?
X
How do you
third.
find out?
X to the 3rd. How do you find out what, Aaron? Ask.
X next squared.
It always goes in this order. Your columns are always going to go. Remainder, constant. X. X squared, X to the 3rd, X to the 4th, 5th.
So
That's the order that forever. But this one only goes up to x squared because when you divide them, you get 1x squared plus 4x plus 7 is my constant, and my remainder goes over what I divided by.
I get that.
Let's do another. Let's see if you got it.
Okay, and that's going to equal 9 divided by.
So it equals, yeah, this is the answer.
Why is the remainder over the x minus 1?
Just like when we did long division, remember you put it over what you divided by? Got it?
Can we do
Okay.
like 2 instead of 1 for the like x minus number?
What you mean?
Like you did x minus 1. The next one, can we do like a number other than 1?
Oh yeah, sure. That's what we're gonna do. Let's see. Let's do. I'm gonna throw you off a little bit. X cubed minus 4x plus 6 divided by x plus 3. So my first question is, can we divide this synthetically?
Yeah.
Yes. So set it up. What goes on the outside?
Negative 3.
Negative 3.
Negative 3. Sign.
What goes on the inside? I hear one. Oh, good job. Somebody caught it.
1,
I was trying to throw you off.
4, 6.
You need a placeholder, absolutely. You
Why?
definitely need a placeholder. There's no squared term there, and you've got to have that column in your answer.
Oh.
Why is the 3 negative?
It's opposite sign. It's always the opposite of this. So before we were x minus 1, so we put positive 1. Now remember how long these long division took you. Look how quick these synthetic go.
Very quick.
Very quick. Not nearly as much room for mistake, right? Because we're not having to multiply around, subtract, same, change everything. All right. I'm going to go ahead and do it. Most of you look like you've gotten it already. Drop the first one. Multiply. Add. Multiply. Add. Yep. Multiply. And add. Anybody lost? Okay, where'd I lose you? After the 9. This 9? Okay, so I added those. Negative 4, 9 is 5. Then I start the whole process again. Negative 3 times 5 is negative 15. And then I add that column together. Do you have a question, Ozzy?
How did you get 9 itself?
9? 9 came from negative 3 times negative 3, which is 9.
I get
Add.
negative 3. Oh wait, so
Yeah, I know that.
in
But
the
after
negative 3.
Right, you keep referencing this negative 3 on the outside as you go through.
Yeah, to get the negative 3 over there, you times.
Yeah, I see that.
The negative 3 over there comes from here.
Oh, so
Outside.
1 and negative 3 equals negative 3.
Right.
Yeah.
The first one always just drops down.
And then you're gonna add the 1 plus negative 3 plus, like.
No, this is
to get the
my
answer.
yes, you do.
So are we taking it all the way out?
We are. I'm fixing to show you. Yeah. Daniel, do you have a question? Okay. Everybody's with me then on that. Yes? All right, so now label your columns. Start with the remainder. Yes.
Constant.
X squared.
So this divided by this is 1x squared minus 3x plus 5 plus
Negative 9 over x plus 3.
what you think?
I like it.
So you do add all this together.
Yes. Okay. So let me show you how we're going to use this. Y'all thought that was all right.
Honestly,
We got more?
Okay. This is still the same section with long division. We're breaking it into 2 days. Think about something with me for a minute. If something has no remainder when you divide, tell me what that means.
It can go into it evenly.
Yes. Give me a vocab word. Okay, another one. Factor. It's a factor, right? And since we've been factoring, I hope it all comes together for you today. Okay, let's look at it with numbers before we look at it with polynomials. Some of y'all are looking at me like, oh my God, what are you fixing to say? Okay, if I said, what is 6 divided by 3? Do you agree that there's no remainder?
Yes.
So because there's no remainder, that tells me that 2 is a factor and 3 is a factor. Do you agree with that?
Yes.
And what happens with those two factors? In other words, how can you rewrite an expression or an equation given those two factors?
3 times 3.
You agree with that, right? So I could say that 3 times 2 equals 6. I could multiply these two factors together. So you agree that when you divide by a factor, you get another factor, right? And that those two factors multiplied together give you what you started with, right? Dun, dun, dun. So what if? Let's see. Let me find one that doesn't have a remainder. This is exciting. Look at this one. Let's say I told you that this polynomial, x cubed minus 10x squared,
You would have to write that.
yeah, plus 19x plus 30. If I said, okay, I've got this polynomial, one of the factors of this polynomial is x minus 6.
Okay.
Given that factor,
Divide.
factor the polynomial completely. So you're right. My first step would be to divide, because if I've got one factor, I need the other, right? Because remember, factoring, yeah, it was given. This is all given. Factoring is just the process of taking something and breaking it down in pieces that multiply together, right? Well, I don't know how to, if I tried to slash this, it wouldn't factor, so I don't know how to factor that. But if you give me somewhere to start, I might can figure it out. Does that make sense? Okay, so we all agree when you divide by a factor, you get another factor. So let's find another factor and see what happens. So, do we all agree that I can divide this synthetically? Why?
Because it's
X
X
minus a number. No coefficient, no exponent on X, yes?
Yeah.
Okay. All of these you'll be able to divide. I'm not going to give you these where you have to start long division, okay? All right. What goes on the outside?
1. Negative 1.
6.
6. Look at your factor. What are you dividing by? It's okay. Look what you're dividing by. I give you all of this. So what you're going to do is you're going to divide by this factor, right? So I changed the sign. So it's going to be a
6.
positive 6. Now I need my coefficients. What are they?
1.
1,
Negative 10.
negative 10,
19.
19,
30.
30. Is anybody lost?
No.
Everybody's tracking right along with me, yeah?
Yeah.
Okay.
Bring the one down there.
Bring the 1 down, absolutely.
Then 6 on one.
This is constant. Multiply, add, multiply, add, multiply, add until you get to the end, okay? What am I multiplying?
6 on one.
The 6 on the outside, right? That's what keeps going to everything. 6 times 1 is
6.
6. If I add those, I get
Negative 4.
Negative 4.
6 times negative 4.
Negative 21.
Add those.
19.
Negative 5.
Negative 5. Yeah.
Multiply.
Negative 30.
Oh, look what happened. Which should have happened, right? Why should that have happened?
It's something crazy.
I got a 0 as a remainder.
Oh.
Because it's another factor.
It's a factor. They told me that in the beginning. They said this is a factor, and you told me if you divide by a factor, it goes in evenly, right?
Yeah.
Evenly means no remainder. So if you divide by a factor and you get a remainder, something's wrong. Does that make sense? Okay. So, do you all agree now? Y'all stay with me. This is exciting. If you divide this by this, you get this. Yes? Do you also agree? You told me you could rewrite it as a multiplication problem, yes? Do you also agree that you could say if f of x equals this, then f of x also equals, keep going. Do you agree with that? Can you finish factoring that now? Yes. This is your remainder, constant, x, and x squared. Do you see where we're getting with this? Are you confused, Tanner? You just, why?
X.
It's fun. It's so fun. What?
But it's just
X minus 6 is what I started with. So remember, if you divide by a factor, you get another factor. And you can absolutely multiply those two factors together to get what you started with. Okay. And now I can finish factoring it because that is a quadratic and I am a pro at factoring quadratics, yes? I'm speaking for you now. I hope you are, especially when there's no leading coefficient here. That's easy peasy.
Yeah, just go ahead and do it.
So go ahead and factor that quadratic and see what you get. Some of you have already done it, and others of you are looking at me like I'm speaking another language. If you need to put that one in the box, put it in the box. When there's no leading coefficient, it's pretty easy because what multiplies to this and adds to that.
Oh, this how we got it. Oh, yeah, this way. Oh, yeah.
What you think? Given one factor, can you factor completely? Really, there's only one thing that we did. We changed the way we divided. If you have to long divide it, you'll get x squared minus 4x minus 5. But that's a lot if you choose long division on that. Especially when we get to PRZs tomorrow. Possible zeros where you have to start testing which ones are. Until you find the one that works. So if you test them with long division, you'll be testing forever. All right, tell me what you think about that. Okay, the only reason I'm not doing another example of that is because the next thing I'm fixing to show you uses this to do one more thing.
It's another one?
Yep. Look at this same problem. Exact same problem. Boom, look at the factored form. If I said, okay, class,
Oh, never mind.
since you're so smart, what are the zeros of this function?
Hold up.
Another.
5 and negative 1.
Good job. 6, 5, and negative 1. Do we all agree? Does everyone know why?
Because x minus 6 equals 0, x minus 5 equals 0.
Setting the function equal to 0 and solving gives us the zeros, right?
Oh, they're just solving.
And the zeros are the places where it does what? Crosses the x-axis. Good job. It crosses the x-axis where the function itself equals 0. So if I found the zeros here, I would say x equals 6, x equals 5, and x equals negative 1. These are the zeros. So, let's see how well you did understand this. What if, instead of giving you a factor, I give you a 0?
So we just be reversing
Can we
everything.
do the same thing?
No.
Yes.
Do you see? Look what's happening.
Yes, you can.
Look at, yeah, you can. You can. See, even your classmates have this. If the factor is x minus 6, what's the 0?
6.
6. So if a 0 is 6, what's a
It's the
factor?
opposite.
X minus 6.
If a 0 is 5, what's one of the factors?
X minus 5.
X minus 5.
So therefore, oh, I'm getting excited. I'm getting chill bumps. What if I told you,
Not me.
yes, this is fun.
No, it's not.
Wait till we get to PRZs tomorrow. I love PRZs.
What is that?
X minus, and I'm going to say, I'm going to put zeros in quotes because I'm not talking about the number 0. I'm talking about a 0 of the function. X minus any 0, and I'm saying minus because the sign's got to change, right? Whatever it equals. So x minus 0 is always a factor. And if you have a factor, then you can divide and you can find the other zeros. Yes? Let's do one.
Why you
This,
like factor?
this, by the way, is called the factor and remainder theorems. These two theorems that we're working with right
You
now.
factor in the whole year.
Oh, hush and do it.
Good, you like this lesson.
It's fun. It's fun because it brings everything together and you start seeing how it all comes together from what factoring does and how it...
Good, you got 100 in every class.
Quit hating on him!
How? That's not hating. That's giving him a good compliment. Rising his standards.
He don't need to rise his standards. What are you talking about? All right.
Did you listen to Yellow Boy?
Here's the only thing I'm going to give you, and you have a couple of these on your test. So listen. You'll have a couple that'll say, given the function and a factor it completely. That's what we just did. But then you'll have some that'll say, if this is the function and -3 is a zero of the function, find all the other zeros. Well, let's think about it. If -3 is a zero, then what is one of my factors?
Plus 3.
X plus 3.
So you're going to divide it by it.
Oh, I didn't mean to put zero, I meant to put factor.
Where did that come from? Oh, you talking about that -3?
Right.
Oh, that's like a, what kind of mark that is? That little line thing.
That's a semicolon.
Oh, yeah.
Okay. So now, by interpreting what the zero is, right, I found a factor.
Yes.
And if I have a factor, I know I can factor completely and set each piece to zero to find the other factors, right?
So you do the -3.
Yes. All right, so here's where I'll caution you, because here's where students mess up. When you are synthetically dividing, the number outside, okay, if you're given a zero, it's the same sign as the zero, but it's the opposite sign of the factor. That's where you're going to get confused as to when you do the opposite sign. So if you need to make yourself a note, same sign as the zero, opposite sign of the factor. Okay? All right, let's divide.
Wait, same sign as a zero is opposite sign?
Yes. See, this is my zero. I was given a zero. Same sign as the zero. But if I look at the factor, it's the opposite sign of the factor. Okay? Give me the coefficients.
1,
1,
-2,
-2.
1, -18.
Good job.
Bring down 1.
Bring down the 1.
Bring down the one.
Multiply.
-2.
Now remember, imagine if you're doing long division on all these. Holy crud, we'd be here forever, right? You only had like 6 problems to do for homework on long division.
Just be at 6 in the morning.
-5. Oh, was it 10? No.
No, we had 7.
7, yeah. 3 to 10.
7.
-3 times -5 is positive 15.
No, you following him.
-21 plus 15. I hope it's -6 because I need this column to be 18 so that my remainder is 0. Remember again, if I'm dividing by a factor, I better get a remainder of 0 because that's the definition of a factor, yes?
Yeah.
Write it as a multiplication problem. Oh, hold up. Okay. Sorry. I get excited. This is good stuff. Good stuff.
No, it's not. You don't like us talking about your math, man.
I know, because this is fun.
I never go major for math.
Wait till we get to PRZs, we get to use everything we've learned so far in one problem.
I'm gonna be this really weak kid.
Yes.
Does that include the quadratic
You got a
formula?
graph too?
You can.
Graphing, quadratic formula, everything?
Some of them, I'll show you why in just a second. I'm gonna show you why. Yes.
Reading your shirt.
All right.
Oh.
What's that say? Some idiot is reading my shirt.
Less than 10 seconds.
I didn't even buy this. I just found it one day. And I just,
What's the bottom say? Less than 10 seconds ago.
yeah.
Okay.
Probably
Let's write it as a multiplication problem. X plus 3.
How do you get that? I'm really confused.
How'd I get what, Tanner? If it gives me the 0, X minus the 0 is a factor.
Okay, so we can just go ahead with that.
Mm-hmm.
Next to the second
So
line,
it's going to be
5,
opposite
8,
as
6.
that 0?
Yep. Now,
And that's the
somebody asked a good question. No, because my directions were find the zeros of the function, which means I need to set it equal to 0 and
answer.
find.
Zero's
Now,
-3.
that's one of the zeros, but how many zeros should this function have?
3.
3.
Right? So, somebody said, what about like quadratic formula and everything? Well, here's the thing. What if I couldn't factor this anymore?
You just leave it there.
There, you can't just leave it
I
there.
can't even see.
plug it in the quadratic.
You would have to plug in the quadratic formula, or you would have to complete the square, or graph it and find the x-intercepts.
We gotta do that.
If it doesn't factor, does this one factor? Yes, this is a nice factor one. It factors as x minus 3, x minus 2, which means what are the zeros of the function?
-3, 3, and 2.
Absolutely. Woo! Was that fun? Nobody in here thought it was fun.
I mean, the first part.
Nobody likes math.
The directions asked you to find the zeros. To find the zeros, you set it equal to 0 and solve.
To the 0.
How we got the two though?
So your remainder is 0.
So that's nothing.
Right. And it should be nothing if you divide it by a factor.
So then you don't.
Oh, you put it in the zero.
Correct.
Where did you get -3 and x minus 2?
If you set each of these pieces equal to 0, x plus 3 equals 0, x minus 3 equals 0, and x minus 2 equals 0 to solve, you subtract 3 from both sides, add 3 to both sides.
Oh, yo, it's a yellow boy.
I factored this.
Wait.
Put it in the box.
Yes,
Did I mess up?
You factored it wrong.
No, I didn't.
Yes, you did.
It's minus.
Oh my
Minus 6 plus
gosh,
4.
I did. Thank you.
Where's the entire birthday party?
Thank you, guys. I'm getting so excited.
I guess you were wrong when you said that we're having a mistake. What? Did I say that the first time? And I'm like,
Thank y'all. I did it whenever I saw y'all's hands go. I was like, oh God, I've done something wrong. Because it's got to multiply to -6, but add to -5, and they're going to be mixed signs. 1 plus 1 negative.
what did you do? What did you do earlier?
You said they got a what? Oh no.
I did it as a same sign one. I was thinking that was +6 on the end instead of minus.
But if you add
Ah!
2, what did you get?
So yellow was in
5.
No, you don't.
But it's got to be opposite signs. If the second sign is minus, the signs are
Let me
mixed.
say that, but Lennon was telling me to call.
If it was -3
Yes.
plus -3 plus 2, you would still.
Well, it can't be.